Hello, campers! My name is Tiberius Archimedes Bingopolis. Wait, what? Try again. Tiberius Archimedes Bingopolis. You try it. Yeah, that's what I thought. So, you can call me Bing. Today, we're going to do science. But before we get into the experiment, I have a quick question for you. What is science? So the question is, what is science? What is science? What do you think? Well, there's, say, chemistry. Is that science? Hey, this pen's not working. There's physics. What about stars? Studying stars. Yes, all of those things might be science. There's the science of sound and the science of eyes and the science of flying. There's all kinds of science. But my question actually is, what is science? And I know you're going to get a lot of different answers from a lot of different people. But here is Bing's answer. So Tiberius Archimedes Bingopolis, you can quote me. Here is what I think science is. Science is asking a question and looking for an answer. Science is asking a question and looking for an answer. You can quote me. Tiberius Archimedes Bingopolis. Bing says science is asking a question and answering it. All right, it's science time. We're going to do the experiment now. Everything you need should have been provided. All right, it should have been in that little plastic bag. So, what you should have is a pen, a dryer sheet. Haha, lovely. You should have a little piece of wool. You should have not one, but two balloons. Now you'll notice I blew them up first. Takes me a while, so I went ahead and did it. Your first job is to blow up the balloons. All right, once those balloons are blown up, I want you to on one balloon write sock. On the other balloon, I want you to write dryer sheet. Okay, do that. All right, now we need to record our observations and predictions. Now a prediction is a guess, right? A prediction is, what do you think is going to happen? You should always write that down before you do an experiment because it's important. It helps you understand what is going on. You make a reasonable guess and then you perform the experiment and you compare what you saw with what you guessed. So the first thing we're going to do is we're going to set up our grid on a piece of paper. You want to do that. All right, so it's 3 boxes times 2. All right, in one box, we're going to put sock. Right underneath it, we're going to put dryer sheet. Can you see that? All right, sock, dryer sheet. Now, the next box over is where we're going to record our prediction, which is our guess, okay? So you see that? See where it says there, prediction. That's where we write down our guess. And don't cheat. Write down before you do the experiment, because what comes next is the observation. Yes, that's where we write down what we actually saw. So Here we determine which one we're working on. We write our prediction or our guess, and then we write down our observation or what we saw. All right. Then we're going to move this direction. We're going to have all that written down when it's done, and then we're going to compare what we thought was going to happen with what actually happened. Go ahead and do that. Okay, here I have set up my board. I'm going to bring a little closer so you can see. However, I have covered up my predictions. Can you see? Here's my predictions, but I covered them up. That's not fun. Sorry, guys. I'll let you do your own fun, though. We will, however, write in our observations, and then we're going to see how those check up to our predictions. Now, this is a really important part of the scientific method, we call it, which is the process for answering the questions that we asked. All right? The scientific method includes making some sort of intelligent guesses about what we think should happen, and then we do an experiment and see what happens. Then we can go back to our guesses and see if we were on the right track or not. And then we just keep doing this process until we develop a better understanding of what's going on. And that's really the entire process of learning, right? You try something out. If it didn't work, you try something different until it works, and then you try to explain why it worked. Welcome to science. So we're going to go through the entire experiment, and then we'll check our predictions. So this is an experiment about static electricity. All right, have you ever rubbed a balloon in your hair and stuck it to a wall, or screwed your feet across the floor and shocked your brother or sister or mom or dad or someone? That's static electricity. And what's going on is actually a very complicated process, but simplified, when two things are pressed together and rubbed, they create friction. And friction affects the molecules and then ultimately the atoms of your matter. All right, atoms are little teeny tiny building blocks of all matter. All right, but friction affects them such that it creates static electricity. And as you know from static electricity, whether you have stuck it to a wall or something, there's a stickiness to it or a pushing awayness to it. Either way, it's kind of a similar effect as magnets, right? In fact, it's very similar to magnets. But what's going on is a transfer of electrons creates an imbalance of charge, and that imbalance of charge then pulls things together or pushes things apart. All right, now we're going to start with the balloon with the sock written on it. Sock. All right, so first thing you're going to do is you're going to take the sock and you're going to rub it over the words. You're going to take this, wait a minute. Ah, that's right. We need a sock. Here we go. Oh, there we go. Now we have a sock. Okay, woohoo! All right then, moving on. So now you're going to take sock. You're going to take your sock and you're going to rub right over the word sock. Okay? 10 times. Set that aside. Now you're going to take the wool. You're going to rub right over that word again. Sock. 4, 5, 6, 7, 8, 9, 10. Okay? You're going to set that aside. You're going to take your can. You're going to put it down. Let's see that again, in case you missed it. You're going to hold it close and see what happens. Wow. And there you go. So what happened? What happened when you did that? Did it move away? Did it move towards it? Write that down. Okay, now with the dryer sheet balloon, we're going to go through the same process, only first we're going to rub it with the dryer sheet instead of the sock. So let's go right on the word. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It smells much better than the sock. And we're going to take this, which is our wool. We're going to go right over the top of that again, 10 times, or 10 seconds actually. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, let's look close to the balloon and see what happens. What happened? Anything? Okay, now just for fun, we're going to keep doing it. Okay, we're going to keep doing it. Let's try it one more time. So let's do this again, just so you get a good sense of what was supposed to happen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we're going to bring it close. What happened? All right. I think that makes sense. Go ahead and write your observations down. Let's take a look at it. All right, for observations. What happened with the sock balloon? Did it move at all? Yes, it did. Did it move towards or away from the balloon, from the can? I think, and the way I remember it, it moved towards can. Okay? Move towards the can. All right. Now, what happened with the dryer sheet balloon? Did it move? Did it not move? Did it move towards? Did it move away? I remember it not moving. All right. Is that consistent with your observations? Did we see the same thing? If not, well, we can always do it again, which would be fine. We should collect more points, but for now, we'll go with these observations. Let's check our predictions. What did you think was going to happen with the sock? I'll pull up mine, and I think it moved closer. So I got that one, okay? My observations were correct. My prediction was correct. Now, what should happen with the dryer sheet? What was your prediction? My prediction was that nothing would happen. All right. My predictions were correct. Now, if your predictions were not the same, well, that's totally fine, right? We're just learning here. You make a guess, and then you do an experiment, and then you have an observation. I can't tell you how many times I have guessed wrong, right? That's just part of the learning process. It's what we all do. Now, I happen to know a little bit more about static electricity, and it makes sense to me that these predictions and observations are consistent with my understanding. All right, so let's touch base a little bit on what was going on. All right, if you remember, when we rubbed this balloon, this was our sock balloon, with the wool, what we ended up doing was transferring electrons. So whether it makes any difference to you or not, we created a charge right there at the tip there. So like when you rub the balloon and stick it to a wall, the same thing happens. It creates a charge, and then that charge becomes kind of sticky. All right, so as you get close to the balloon, as you get close, it moves towards the balloon, like it wants to stick to the balloon. Well, what was going on with the dryer sheet balloon? Well, if you've ever taken your clothes out of the dryer, and I'm sure you all have because you all do your own laundry. If you've ever taken your clothes out of the dryer, you start pulling out, you get like little little sparks and things, and they all stick together, right? Well, dryer sheets were created not only to smell lovely, but also to deactivate static electricity. So there's a little bit of a coating on here that works its way onto the surface of the balloon, and then, okay, so we've coated the balloon with an anti-static chemical. Then we take this and we rub it and we try to make static electricity. Don't do that too hard though. Might pop in your hand. That wouldn't be good. And then as we bring it close, you'll see nothing. Nothing happens. That's why dryer sheets were made. So it's nice to know that they work, right? It coats them with just a little bit of a chemical coating that then deactivates the static charge. And you can see this in your observation when it doesn't move the can. So that is our experiment. If you go ahead and read the mystery, you'll see it walks through this whole process. And you can see in the end who sabotaged the race. It's actually pretty exciting stuff. And science itself. We asked a question, we answered a question, right? What will happen when? That is always a great question to ask. Unless it's what will happen if I jump out of the top of a tree. Let's not ask that question and then find out. That's science. And science is, in fact, brilliant. Brilliant! You guys have a great day.